significance level to determine if, what do we determine? If a person's taste for chocolate depends on their age.
Oh, that's nice.
Do you think it does?
Did you put students?
Yes, it depends on who your population is, depends on their age. If my population was just anyone, then I would put just a person. I just want to know adults, right? But if it's or like people 18 or, well, I guess I don't know, 17 or over is what I have. If I wanted to know, does a student, then that's how I would write it, right? My sample would be a poor one if it were just anyone, because obviously they're all students. Okay, let's see, depends on their age. And then I will go ahead, I'm going to say students' taste for chocolate, which is the dependent variable. Depends on their age, and I'm going to write independent variable. All right, null alternative, here we go. Insert equation, and I'm going to do H naught. And this is rho equals 0. And for the alternative, I'm gonna make this not bold, by the way. Okay, and the alternative, I don't know if it's going to be negatively or positively correlated. The older you get, the less you like chocolate, or the older you get, the more you like chocolate. So I'm just going to do not equal to. In fact, I'm going to cheat a little bit too. I'm just going to copy and paste this here. That way I can just change a couple things. 1 and not equal to. There. Okay, so here I go. I don't have to sort anything for the linear correlation, which is nice. So I'm going to actually conduct the test here. And I'm going to go to data analysis. And again, it's hard to see, but it says correlation. And then OK. Okay, my input range is age. Oh, I have to do 2? Hold on one sec. So I guess I'm going to do age, and then I'm holding down control. What was it? We're doing chocolate. Where's chocolate? There it is. I'm going to hold down control and then press chocolate. And it says columns, and I have labels in first row. Input range. Did I do this wrong? Hold on one sec. Let me go back for a second. Data analysis. Oh, sorry. No correlation. We want to do, take it back. I'll edit that part out in the video. We want to do regression. All right, sorry. So we hit regression. And if I can get over, say OK. There we go. The first one, I have to almost come up here and need glasses. Y range. All right, so I'm going to select the Y's. Let's see, the Y was chocolate. And then now I select the X range. The X range was age. I have labels. And I'm going to click OK. Let's try it again. I believe, so what happens sometimes, and this is actually, it won't happen in yours because your data is nicely cleaned up, but this is, I think half of data analysis is actually cleaning the data. maybe even more data analysis is actually cleaning the data. Maybe 90% of data analysis is actually cleaning the data. And some of you guys may not have actually written a chocolate score, and some of you guys may have not written an age. So if it doesn't match up, right? So if I asked Sarah how many hours she slept, but I don't have a matching happiness level for that, it's like, wait, I have 40 and 41 here. I can't do that. So, darn it. Let me just do it this way. I'm just going to cheat. I'm just going to say my Y range was chocolate, and I'm going to do up to 20. And then my X range is age. Oh, that's not going to work. I'll do more than 20. Let's see. Let's try. I just can't even read it. Darn it. Here, this is what I'll do. I'll sort it by age, and I should have. No, I've got all the ages. Now you got all the chocolate. I'm looking for empty ones. Why isn't it working? All right, sorry. Data analysis, regression. Okay. I want to do, oops, I'm doing the wrong one, sorry. I want to do age for Y. Go up and do it again. No, not age, sorry, chocolate for Y. So here we go. And then we'll do age for X. That was up through 80. Oops. Oh my gosh. Oh, I'm going to read this. That says 80 and that says 98. So let me just back up. So 80. Try to. No labels. Whew. Okay. Sorry. It's really hard to do this when I can't really see. Let me. Okay, so again, you shouldn't have that problem where it's giving you an error. I don't know. There might have been something in my data that was, I just don't want to take the time to go look and see what it was. So I just took 80 of them. And what I got was that my R is 0.11 and my R squared is 0.01. All right, so is there, if my, let me write that down. R was equal to 0.11 and R squared was equal to 0.01. Do I reject the null? Oh, let's see. Let's look at the p-value too, huh? Let's see. It's not giving my p-value? Oh, I think I have to scroll down. There we go. Okay. Okay, I'm glad I looked at this because there's a lot of stuff. There's a lot of different ways to do regression, and I'm not teaching you all those ways for sure. You can do like an ANOVA regression. You could basically do an F test or a T test for regression. Don't worry about all that. What we want, these are p-values for the intercept and for for the slope. We want to do, this is the slope, x variable 1. This is the one we want. That's the way they say it on Excel, and a lot of places they do intercept and slope. But this is the slope, so the p-value is 0.33. So, do I reject the null? I fail to reject. 0.33 is not less than 0.05. So here I go. Let me try and finish this up. All right, so I fail to reject the null hypothesis at the 5% significance level. Something like there is insufficient evidence to show that age and chocolate and taste for chocolate are linearly correlated, which by the way, I really wouldn't have imagined that they were. And then I have, let's see, my test statistic. So again, this is the row that I want. My test statistic is 0.98, and my p-value is 0.33. So I have t equals 0.98, and I could either write my p-value or just that it's greater than 0.05. And if you reject the null and it's linearly correlated, then you should say something like, well, I'm going to go ahead and write it in this, although this doesn't really make much sense. And I'm going to say, well, approximately r squared amount. So approximately 1% of the variation in taste for chocolate is explained by the least squares regression line, and then regressino line, y equals mx plus b. Does it tell me what that is? Oh, it does. Here it is, the coefficient for the intercept and the coefficient for your x variable. That intercept is b, so this is y equals 0.42x minus 0.18. Again, this one's b, and this one's m for slope. Y equals 0.42x minus 0.18. Okay, and the only other thing that you need for this is a scatter plot. So I'm going to call this figure 1 scatter plot. Something like that. And it's quite easy to do a scatter plot for here. I'm going to do insert scatter plot. Let me do it this way. What was it? Age and chocolate. And terrible scatter plot. I only did the first few, I just highlighted the first few, but the idea was all of the people I highlighted were either 18 or 19, and this was the distribution of how they liked chocolate. All right, so there you go, but I'm going to go ahead and you could write, I'm not even going to change this, but you can edit that and then plug it in here. All right, so you're welcome to, I wouldn't leave that necessarily just as chocolate, but something like chocolate scores, chocolate versus age versus chocolate or something like that. Okay, and then that's done. You can see that only took us like 10 minutes versus the ANOVA, but you need to know how to do both of them, but you only have to pick one of those, either correlation or ANOVA. So sorry it took so long to explain those, but hopefully that gave you a good idea of how to do step 6. Before we go on break, are there any questions? Okay. All right, come back at 11:15 and we will continue with the notes.
So I have some questions about this one. I tried to do it at home and I was thinking, I got stuck on this. I was like, if you want to do a scatter plot, do I do A, B, C, D, E, and G on the bottom and then do separate lines for these two?
So, like David Yang is A, right? He slept 5 hours, he's a happiness of 6. So how would you plot that? How would you plot David Yang? Slept 5,
what
happiness 6.
I was thinking that put the A, B, C, D.
Now, but just listen. So this is how, like, we just did this one. David Yang, happiness, 5, or sorry, sleep, 5, happiness, 6. How would you plot that? How did we plot that the other day, the sleep and the happiness?
What? I wasn't here, that's why I was
Okay, so we plotted sleep versus happiness. Right? You go to 5, 6. Because that right there, that's David's point. Now you go to another point, right? And they slept 1 hour and there is 4, whatever it is. And here's me and here's you and you know whatever. But like, so just because it says couple A, B, C, D, E, F, G, you know whatever, it's just, you could do wife,
all the wife,
husband.
and then husband, and wife on top, or?
Yeah, that part doesn't matter. If husband depend on wife or does wife depend on husband?
And then the R2 part, I just...
It's the correlation coefficient. I mean, it all comes from your calculator.
Okay.
So, yes.
Show you step 5 before I
Independent z-test. Okay, so I need to do it to make sure that this is like actually the numbers are right, and then I'll get back to you. Okay.
When are your office hours?
Could you write your name on it? My office hours, I have office hours Monday 1:30 to 3, upstairs, or sorry, actually right next door. And then Tuesday from 12 to 1. And then I have online office hours on Friday, but I can also just do appointment. I mean, I'm here today, I'm here after class.
Okay,
I
and
can
where
be
you
here.
in class, like next door to you?
After class, I'm in OAB 271. 270, not 279.
Okay. And then I was here yesterday, but I forgot to sign in, so I just wrote it over.
That's fine.
Yeah.
Yes.
I don't think my group is going to be here anymore.
Very possible.
And one of them has my step 5, that's why I have a 0 on it. So, and she's not replying to me, I don't know what. Because I don't have another like thing for step 5.
You gotta redo it.
Okay, and then it's just going to be me, so I'm just giving you a heads up.